This meeting.
Okay, from our previous class, we discussed about what is spanning tree, why it is used, how it can avoid the loop in the network. We discussed about what are the different port states, like designated port, root port, blocking port, right? Alternator blocking port. And we also talked about what are the different states it has to pass through to go to the forwarding state, like discarding, listening, learning, forwarding and blocking state. And we also have gone through the different modes of spanning tree. We talked about multi-spanning tree, per VLAN spanning tree, and we talked about rapid spanning tree. So any questions from our previous class, guys?
No, sir.
Okay, so I'm going to quickly demonstrate the lab for the spanning tree. We'll just go with the traditional spanning tree and then see how it avoid the loop in the network. And then we'll start today's topic about port channeling. What is the advantage of port channeling and why it is used, and what are the different modes of the port channel. And we can quickly complete the port channel lab as well. So I'm going to quickly share my screen and then do the lab. So just like yesterday, I'm going to take 3 switches. Okay, I'm going to connect them in a looped fashion. So by default, as we know, they all will have the same priority, 32769, 32768, right? That is the default priority. So by default, let them all come up on the ports, right? So this is 0/1, this is 0/2. So they will exchange the BPDUs, right? They will exchange while we are talking, they will start exchanging BPDUs and they will block one of the port by default, right? So let's give it a minute. Looks like this port is blocked and all the other ports are allowed. Okay, so it looks like spanning tree blocked this port to avoid the loop. You see this color, the orange color, that means that it's not blocking, it's not putting the port in the forwarding state. So let's go here and then check whether it's blocked by spanning tree or not. So I'm going to log into this switch. I'm going to do enable and then do show spanning tree. It says 0/2 is BLK. BLK means blocking. That means that it is blocking this port to avoid the loop in the network. Okay, so let's see why it blocked. Okay, look at the priority 32769. That is the default priority. Let's look at the priority here. Enable show spanning tree. 32769 is the priority here. Come here, then check. 32769. So can anyone tell me what is the condition if all the priorities are equal?
So we will check the ports based on the ports, like we will choose which needs to be forwarded, and we can also block it.
No, I'm asking.
Yeah, based on the MAC address.
We can check the MAC address.
Yes, whichever is the lowest MAC address, that becomes the root bridge. So let's see what is the MAC address of this switch. Okay, so the MAC address of this switch is this one. So I'm gonna copy. Sorry, let me double check the bridge ID here. So the bridge ID of this one is this one. I'm gonna copy. Let's check the bridge ID of this one. So because this one is 0002 and this one is 00D0 and this one is 00E0, looks like this one is definitely smaller than these two MAC addresses because it starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 means A, 11 means B, 12 means C, 13 means D, 14 means E, 15 means F, right? So that this tells me that 0002 is the smallest one. So whichever is the smallest one, will that become the root bridge, guys?
Yes, sir.
Yes. So which has the smallest MAC address, that becomes the root bridge. So out of these three, this one is the smallest MAC address. Now let's check whether this one is root or not. Okay. So to check that, show spanning tree says this bridge is root. Okay. So this bridge is root. So that is what it's saying. This bridge is the root. So this one is the root bridge. What will be the ports on the root bridge, guys?
The one that
Designated routes.
They are called
Designated
designated ports, right? The ports on the root bridge are called designated ports. So now let's check whether the ports are in the DP or not. So when I do show spanning tree, if you look at the port, one role is designated port and designated port. So this one is DP and this one is DP. What are the ports closest to the root bridge called?
Root ports.
Root ports. The ports which are close to the root bridge are called root ports. So this one should be the root port 0/1 on this one. So 0/1 is the root port, right? This one is the root port. Okay. What should be the role of this port, guys? This
it
one.
is an alternative port.
This is the port close to the root bridge, right? So this should be the root port, correct?
Yeah.
So let's log into the switch and check. So what is the port number? This is 0/1. 0/1 is the root port. So what should be this port, guys?
Alternative port.
Block
It's
port.
blocked or alternate port. Correct. Yes, blocked port. So this is blocked or alternate port. Role is the alternate and state is blocked, right? So this is it's blocked. Okay. And this one should be obviously DP. Okay. Okay, so that is how spanning tree did the initial blocking of the loop. So now I wanted to change the root bridge from switch 5 to switch 7. So I'm going to go here. Okay. I'm going to go here and then we'll give the lowest priority. Okay. On switch 7, I'm going to define the lowest priority and then see how spanning tree will affect. Okay. So I'm going to go here and then do spanning tree VLAN 1 priority. By default, every port will be in the VLAN 1, right? So I'm going to take VLAN 1, priority will be 4096. Okay. Okay. So now we did this. Immediately, you see these ports started changing the roles. Now let's go here and then check show spanning tree. It says these two are in forwarding state now. Okay. Now let's go here and then check what's going on. Show spanning tree. 0/2 is still learning, right? It is still learning. So out of these two, let's see which one get blocked. Obviously, this one has the lower MAC address, right? Comparatively, this one is the lower MAC address. But initially this one is blocked, but now this one is blocked. See, the roles got changed now. Now let's see. Earlier, if you observe, 0/2 is an alternate blocked port. Now 0/1 is an alternate blocked port because the root bridge became this one. This one became the root bridge. Because I did the lowest priority on the switch 7, it became the root bridge. So this one is not root bridge anymore. Okay, that one is not root bridge anymore. So this one became the root bridge. So here on the root bridge, this one will become the designated port. Right, so let's go and check. Designated port and designated port. So these two are DPs now. Now this one became the alternate block port. This one become the root port. And again, so this one should become the root port. So let's check that. So this one became the root port. 0/1 became the root port. So that is how we can adjust the priorities based on which one we wanted to forward and which one we wanted to block. But by default, spanning tree will do the job for us by blocking one of the port to avoid the loop in the network. Any questions? Whatever we discussed yesterday, this is what the lab shows. Yesterday is all about theory. Now we just saw what we talked in the theory. Is it making sense, guys?
Yes, sir.
Yes.
Yes, sir.
Okay, that's good. All right, let's talk about port channels now. I'm gonna go ahead and stop here and start my whiteboard. Port channel or ether channel, both are same. It's like bundling of two physical interfaces to create a single logical link. Right? It is like you take two interfaces and bond it as a single logical link. I'm gonna go back to the yesterday example that we took. We have a switch 1 and we have a switch 2. And we have a okay. So now there is a link between them, between switch 1 and switch 2 and PC1 and PC2, right? So this is the topology. Now this one is in 10.0.0.1. This one is 10.0.0.2. Okay. Now, do you guys see any issue with this topology? Do you guys see any issue with this topology?
No, sir.
No.
Okay, now I added one more link because let me take a step back. What if this link go down? This link went down, then what will happen? Ninesha, what will happen if this link go down?
Uh, I didn't got the point, sir. Like that's what I'm wondering. So you're saying that switch 2 and PC1 has like one more line which is like looping.
No, I'm just asking. There is no loop here.
The whole system will be down.
Yeah.
Yeah, the connectivity will be broken, right? The PC1 will not be able to talk to PC2 because there is no link between them. Correct?
Yes. Yeah. Yes, sir.
Right? So that's why engineer thought that, okay, I want redundancy. Okay, that's what the engineer thought. And he had done one more link. Now, do you guys see any issue?
No, sir. That.
Anyone
So
in the
what's the
class?
purpose of that link?
It's in a loop.
There is a chance of occurrence of loop.
Yep, perfect. So now you're saying me that there is a loop between these two switches, right? So, but there is no, if I add one more link, there is a loop. But if I use just one link, there is a chance of outage. If that link go down, my entire system will go down. So then how do I fix it? So the problem that can be solved is having the port channeling. So we are taking two interfaces like this, but we are logically bundling them into one interface. So think about like you just have one road, but inside one road, you will have two lanes. Okay, you have two lanes. Your traffic can go via lane 1 or lane 2 to the other side, but this is all one road. Similarly, there is two links, but you're bundling them as a single link. From spanning tree perspective, this is only one link, because if its spanning tree knows that there are two links, it will block one of the link. Correct? So to manipulate the spanning tree, we are bundling it as a single port channel. We are telling spanning tree that it is only one link. We are bonding them together it as a single link so that we can have multiple paths. Even though if one path go down, we have another path to go out the traffic. Okay, that concept is called ether channeling or port channeling or link aggregation.
Is that same like a trunk port, sir?
How is it same like trunk?
Uh,
Trunk port is tagging the traffic with a specific VLAN tag. You can say like this: trunk port is like you are going on a road, you have a toll tag. If you have a specific tag, they will allow you. If your toll tag is not there, they will not allow you. Trunk port is like tagging, but port channel is adding one more lane.
yeah.
Is that clear, guys?
Yes, sir.
Sir,
Okay, now I got a question to the group. So I have, let's say I have two lanes here. Like I have two links here. Like let's say this link is like 1 gig link, and this is 1 gig link. Okay, so now the PC is trying to send, like PC1 is trying to download a big file from PC1. Okay, so the traffic is PC1 is trying to download a image or a movie. Okay, there is a movie in this PC1. PC2 is trying to download that from the PC1. So now they start the download, and what is the maximum speed the PC2 will be able to download the file? We have two links here, which is 1 gig and 1 gig. So now what is the maximum speed the PC2 will be able to download the file? Is it option A, 2 gigabit? Option B, 1 gigabit? Option C, 0.5 gig? Option D, 4 gig? Put your answers in the chat and tell me why. Okay. I got a unanimous answer of 1 gig. Can anyone explain me why it is not 2 gig?
As it was considered as a single port, then
Any other answers, guys? Okay, it's just creating a separate line with the same speed. Okay. Okay, someone says 2 gig. Okay. And why is that 2 gig? Because you are thinking that it will aggregate both the speeds. Okay. Okay. Any other guys think C or D? Okay. So the analogy that we have to follow is the lane analogy again. So if I take, you have car 1, car 2. Okay. This is car 1 and this is car 2. Okay. Now you have 2 lanes. The speed limit of this lane is 60 miles per hour. Okay. And the speed of this lane is 60 miles per hour. Now, what is the maximum speed the cars can go? Is it 120 or 60?
60.
Yeah, we cannot double the speed of the lane because the maximum speed the car can go is either on this lane or this lane. So we have 2 separate lanes, but we cannot aggregate them. Similarly, we have 1 gig link here, 1 gig link here. So your download can either happen on this link or this link, but we are not doubling them and making it as double to make it 2 gig. So whoever said B or 1 gig, they are right. And the analogy is just to have a separate link. If this lane go down or if this link go down, you have another path to go your traffic via. So the maximum speed doesn't change. It's just adding 1 more link. Okay. That is the concept of link aggregation. We are logically bonding 2 interfaces as a single link, and we are adding 1 more path for your traffic to flow. Questions? Okay. Silence is gold. I'm going to go and tell the modes of the port channel. So now we have different modes of the port channel. So port channel will have majorly 2 types of protocol. One is PAGP and the other one is LACP. And we also have a static bonding. So now let's start talking about static bonding before we talk about PAGP or LACP. Okay. So in the static bonding, what we are doing is we are manually putting this port and this port and this port and this port. We are forcing them to be a port channel. So that is the static bonding. When I mean force, so this side of the link can be 1 gig. This side of the link can be 2 gig or 4 gig. There is no negotiation happening. They are not trying to negotiate on the speed. We are forcing them to be on the port channel. Then what will be the issue? This side, the PC will keep on sending the data at 2 gig per second. But on this side, it is not capable of receiving the packet. So it has to store in the buffer. So it will send like fastly packets. This one will send, receive, it waits, take one packet slowly and waits and sends the one packet slowly because the capacity is only 1 gig per second. Think about like merging two lanes into one lane. What will happen? This car will flow and this car will wait and this car will go because we are sending so much of data at a pace, but this one cannot handle, right? So then one car has to wait in the buffer and the second car has to go because we are reducing the speed. So when you do the static bonding, you're not negotiating on the speed or you're not negotiating on the interface status, like whether it can be interface is up or down, it doesn't care. You're forcing them to be a part of port channel. That is a static bonding without any negotiation. Okay. Can you guys hear me?
We can hear you, sir, but it's like somewhat confusion. Can you please explain it once?
Someone said in the message that they cannot hear me, but is my audio clear? That's my question.
Yes.
Yeah, your audio is clear, sir.
Okay. So so I have a switch 1. I have a switch 2. So here we have 2 switches. So every interface has a speed, right? The speed of this interface is, let's say, 1 gig. Let's say the speed of this interface is 10 gig. Okay. What is the point of we sending the data at 10 gig per second, but on this side it can only accept 1 gig per second? So even though it's sending a lot of packets at 10 gig per second, this cannot handle that amount of traffic at that fast pace. It can only handle 1 gig per second, right? So even though you keep on shooting the packets at that speed, it cannot handle it. So for that, I gave an example of, let's say you have one destination. Here you have only one lane, but on the source side you have 5 lanes. So the cars are coming at each lane at a single time, but in this side it has only capacity of 1 lane. So this car has to go, so all these cars have to wait until this car has to pass away and then the next car will pass. So we are reducing the number of lanes. That's the same concept of speed, right? On this side you're sending speed with high speed, but on this side you don't have that capacity to handle that amount of data.
Got you, sir.
So static bonding is, we are not caring the both sides of the configuration, the speed, the duplex, whether the port is up or not on the other side. We are not caring about all of those factors and we are forcing them to be a part of the port channel. So no one will recommend the static bonding. They will recommend either use LACP or PAGP, which are dynamic port channels. They are not static. We are not forcing them to be a part of the port channel. We are configuring them, but we are asking them to negotiate the parameters before getting into the port channel. Now let's talk about the dynamic port channels, LACP or PAGP, Link Aggregation Control Protocol or Port Aggregation Protocol. Any questions before I move there?
No, sir.
So LACP is link aggregation. Okay, so on the LACP side, so I have Which one? So LACP is open standard, like any vendor in the market. It can be a Cisco, it can be Juniper, it can be FortiGate, it can be Palo Alto, it can be Arista. Any vendor in the market will support LACP because it is a IEEE standard. Because it is not like a vendor proprietary, that some vendor did not have the patent right for this protocol. Any vendor in the market can use this protocol to form the negotiation. Okay. So we have two interfaces. We are bundling together. Okay. So here there are modes on the port. So you put this port, it can be either in the passive or active. Okay. So what does these two modes will do means, active mode means it will try to listen and send the message to form the port channel. So this side, if it's active mode, it will try to send the message that it wants to form the port channel. Here, if this is active, it will also send and receive at the same time that it wants to be part of the port channel. But if it's passive, it will not send the message by itself. It will wait for someone to send the message to be part of the port channel. So if both sides are active, the port channel will form. If one side is passive and one side is active, the port channel will form. But if both sides are passive, if this one is passive and this one is passive, both of them will wait for the message from the other side to get to it to form the neighborship and to form the port channel. So if you take a table, switch 1, switch 2, active, okay. If switch 1 is active, if switch okay, if switch 1 is active, let me do one thing. Hold on. So I think we should have done a little bit different. Okay. If switch 1 is active and switch 2 is active, the port channel will form. Okay. If switch 1 is active and if switch this is switch 1, right? Okay. So this will not work. Hold on, guys. Let me adjust this. Switch 1. Okay. If switch 1 is active, if switch 2 is active, the port channel will be forming. Okay. If switch 1 is active, if switch 2 is passive, then the port channel will form. If switch 1 is active, sorry, if switch 2 is active, if switch 1 is passive, the port channel will form. If switch 1 is passive and if switch 2 is passive, then the port channel will not form. If both the sides are passive, then the port channel will not form. Even though if one side is active, then the port channel will be forming. So that is how the negotiation works. Similarly, for PAGP, PAGP is Cisco proprietary. Okay, it is not like an open standard like LACP. It is not supported by other vendors. Only Cisco devices will support it. It is very same as LACP. It have to negotiate the parameters on both sides. Like speed has to match, duplex has to match, ports have to be up on both sides to bring up the port channel. It's not like a static. It is like dynamic, but the modes are different in the PAGP. In PAGP, the modes are auto or desirable. Okay, auto is very same as passive in LACP. In desirable, it's very same as active in LACP. Okay, so now one. Okay, if switch 1 is active and switch 2 is active, then the port channel will form. Yes. If switch 1 is active and switch 2 is passive, the port channel will form. Yes. If switch 1 is passive, if switch 2 is active, the port channel will form. Yes. If switch 1 is passive, if switch 2 is passive, then the port channel will not form. No. Right. Similarly, now I'm going to change to auto. So desirable, auto, desirable, auto. Okay. If switch 1 is desirable, if switch 2 is desirable, it will form the port channel. If switch 1 is auto and switch 2 is desirable, it will form the port channel. If switch 1 is desirable, if switch 2 is auto, it will form the port channel. But if both switch 1 and switch 2 are auto, it will not form the port channel. Okay. Any questions, guys?
So to form the port channels, we need to have at least one active switch,
Yes,
right?
we need to have at least one port in the active state or one port in the desirable state.
Okay.
If both of them are in passive or if both of them are in auto state, no.
Oh, same with the LACP, sir, or only in PAGP?
In LACP, the modes are active and passive. In PAGP, the modes are auto and desirable. Same
Yeah.
concept, different terminology.
Okay. I just have a question. If both switches are inactive, we'll not have a port channel?
If both the ports are active, we will form a port channel.
Okay. If both are passive itself, like we will not have any port channel, right?
Yes.
Okay. Thank you, sir.
Okay, now what I'm going to do is I'm going to take a lab, connect two switches, and then we'll show you how does this work. Okay. Okay, very simple topology I'm going to take. I'm going to take a PC here, PC here. I'm going to take a switch here. Take another switch here. So basic connectivity I'm going to give. Just like our example, what I'm going to do is I'm going to okay. So I created a loop like this. If it's a loop, the spanning tree will block one of the port between them, right? So let's see if the spanning tree blocked that port or not. Let's give it a second. Says all of them are learning. It still did not block one of the port because it's in the learning state, right? Okay, here it says it blocked 0/3. Okay. Yesterday, someone asked me a question: if both of them have the same distance or same priority, which port it will block? And what is the answer, guys?
The ports, it
Which
will
is
choose
nearest to the bridge port.
Yeah.
No, it will, if both of them are close to the root bridge, it will block the highest Ethernet port. The smallest will be allowed, correct?
Yes, sir.
So in this case, I have 0/2 and 0/3. Whichever is the highest port, 0/3. So that's why the 0/3 port is in the blocked state. So this one should be our root bridge, right? This bridge is the root. This one became the root. Okay. So now we have this spanning tree. It's taking these two interfaces as the separate interfaces. Now what we have to do, we have to bundle them as a single link. So for that, we have to check. Okay, let's see what are those interfaces are. 02, 03. Okay. So I'm going to do config terminal interface range FA 0/2-3. So if I do range command, I can put the same configuration on both the ports at a single time. Okay. So range and then do channel group 1. It's just the port channel number that I'm going to take, mode active. Okay. So I did both of these ports in the active mode. Okay. I did not do in the passive mode. And then I have to create interface port channel 1 just to no shell. Okay. Similarly, I'm going to go this side and then create interface FA, interface range FA 0/2-3 channel group 1 mode active. So what I did both all the ports in the active mode. So will the port channel form, guys?
Yes.
Yes.
Okay. Now let's see how is the spanning tree taking care of this. Now it says it is only port channel 1. It does not have any separate interfaces like earlier. If you observe, it has 0/2 and 0/3 in learning state earlier, but now that is gone. you're seeing only port channel 1 now. They're considered as a single link, and it says shared. It's not a point-to-point link, it's a shared link. It's a port channel. So now, see, if you observe, all the ports are green. And if you observe, this is in the forwarding state, and the port channel is in the forwarding state. And here also, if you observe, port channel is in the forwarding state as well. So there is no port that is blocked. So I'm gonna, now technically, what happened? These are bundled as a single port channel. This is port channel 1. Even though these are two separate interfaces, we logically bundle them as a single port channel. So here, let's go here and then give an IP address to this device. See, now again, spanning tree looks like it's learning again. So now let's see what happened. Forwarding. It's still learning. So for some reason, spanning tree is renegotiating. Let it renegotiate. Let it be, put it in the forwarding state. Yep. Now again it came. And let's see whether it started. Okay. Now it's in the forwarding state. Spanning tree is reconverged again. So it's fine. Now let's go ahead and give the IP address here. So I'm going to go to config interface. I'm going to give this one as 10.0.0.1. I'll go here and then give the IP address 10.0.0.2. Okay, so now let's go to simulation. Let's generate some traffic, but generate some traffic from here. Let's stop. Command prompt, ping 10.0.0.2. Okay, I generated a broadcast packet now from PC0. It's going from PC0 to switch 1. Switch 1 should send the packet on the port channel. It will pick one of the port. It goes to PC1. So you are seeing it's picking the link 1, right? And then it's getting the response back via link 1, and it's getting to the PC0. Okay, so now let's complete this, and then we can shut down one of the link in the port channel. If we shut down one of the link, still also, see, you got a reply now. It's getting response back. Everything is fine. So if I go to this switch 0, and if I shut down one of the link, okay, interface FA0/2. Okay, I shut down this one of the link. Still, the packet will go to port the other link. So let's stop this real time, and then go here, and then so still the packet will go via other link. Even though one link go down, your packet is still able to ping it. So if one link go down, because of this is a port channel, the port channel will have only one link down, but you have other link to go via uplink, and there will no outage. So we avoided the problem of not having redundancy. If one link go down, we have other link to get the traffic out. Okay. Is this clear, guys? Are you able to follow?
Yes, sir.
All right. Now let's see.
So, sir, when you have two ports, so there is no scope for buffer, right?
No scope for buffer. Because we have two lanes which are parallel lanes. Both of the packets can go on any of the link.
Okay, and same in the case of one active and one passive also, right?
Yes.
Like the
yes.
buffer will go to another port. That will be accepted as a message.
Yes. Yes.
Okay, sir.
All right. Now, Nikhila, can you tell me what is the difference between LACP and PAGP?
In LACP, when when two ports are in passive state, we cannot form the port channel. And while in PAGP, when two ports are in auto state, we cannot form the port channel. So while in LAGP, when one port is active or in one port is in passive state, or active and active passive, we can form the port channel, and vice versa for the PAGP.
Oh, I get it. But the biggest difference is anyone else?
Yes, sir.
Okay, Mahita, can you give it a shot? What is the biggest difference between them?
So LAGP can be LACP can be used by any it supports any devices, like like any company can use this LACP, but coming to PAGP, only the Cisco devices will have this protocol used.
Yes. So
Because
LACP is an open standard. Any vendor in the market can support it, but the PAGP is only Cisco proprietary. Only those devices can use it.
Mhm.
Okay, that is okay. Lakshmikant Jampana.
Yes, sir.
If I'm using spanning tree,
Okay.
will my port be blocked in the port channel?
Okay. If you're using a spanning tree,
Will my port will be blocked in the port channel?
no, sir.
Why?
Because when it is having like two ports in active, it can pass, right, sir? So there is no block like blocking the port.
Not clear. Pranay Udayagiri.
Yes, sir. Yes, sir.
Yes,
Can you
my
repeat
question is, when I have a port channel with
Okay.
the spanning tree, will one of the port will be blocked in the port channel?
No, we are considering the two as one port, right? Like as we are taking the active and passive and auto and desirable, right?
Yeah, that is correct. So we are considering both of them as a single link only. It's a logical link. There is no concept of two links. It is acting logically as a single link. So for spanning tree, it just considered as a single link. There is no more one more link in the path. So it will not block any port. Okay. Bharat Reddy Nimma.
Yes, sir.
If I have two links, what is the condition for the traffic to flow? Which path will be taken, whether it's the link 1 or link 2 in the port channel?
It will take any link, sir.
Correct. But why should it take any link? Will there be a condition for that?
Condition.
Yeah, so that's what I'm going to. It's called hashing. So based on the source IP and destination IP, if you know XOR table, so there is like there is a XOR condition or NAND condition. There is like a ones and zeros, right? So there is like 1 0, you'll get an output of 1. If it's like 1 1, you'll get 0. If it's 1 1, you'll get output of 1. If it's 0 0, you'll get output of 0. If it's like 0 1, you'll get output of 0. So there is an OR operation here. If both of them are 1, then only you'll get 1. If 1 and 0 are there, you'll get output of 0. So 0 means first link, 1 means second link. So based on this operation, the source IP 10.0.0.1 and the destination IP 10.0.0.2, they both perform the OR operation, and based on the result, it takes one link over the other. It is just a hashing mechanism that it follows to select one path over the other. But it is not a CCNA concept. I just wanted to give that extra knowledge that it uses an operation called hashing to select one path over the other. But randomly it will pick it just because the mechanism behind that randomness is nothing but the XOR operation, and you can change that. You can change based on the MAC address, you can change based on the IP address, you can change based on the source IP or destination IP.
Yes, sir.
Okay. All right, guys. It's time. I'm going to stop the recording and leave the floor for any questions, and we'll talk about the test, guys. So give me 1 second. I'm stop the recording.